Okay, so picture this. A helium balloon. Just floating away.
Yeah, pretty common image, right?
Exactly. But that simple picture actually kind of gets at the core of a much bigger and maybe more serious story.
Absolutely. Because that balloon drifting off, well, it kind of highlights a fundamental thing about helium, something with some pretty huge consequences.
And that's what we're going to get into today on the deep dive. Why the world might be running low on helium. And this is about way more than just party balloons, trust me.
Oh yeah, it goes way deeper than that.
So to guide us through this deep dive, we've got this really fascinating article from April 4th, 2025, titled, Why All the Helium Might Disappear into Space Forever. I mean, that title alone grabs you.
Yeah, no kidding. It really sets the stage.
And today, we're going to try to figure out together why helium, this element that's actually the second most abundant in the whole universe, is so incredibly scarce here on Earth. And we're going to trace how it went from this sort of scientific oddity to a totally crucial resource.
Right, like how did we get here?
And then, of course, we have to consider what a shortage could mean. For you, for me, for everyone.
It's a big deal, that's for sure.
So let's start with the basics. Helium. It's the second lightest element, second most abundant in the cosmos. You'd think it would be everywhere, right?
Yeah.
But this article makes it clear that's not the case on Earth. Not at all.
Here, it's super rare. Why is that?
Well, it's all about helium's unique properties, really a combo of things. Like the article points out, it's what they call an inert gas, meaning it doesn't really like to bond with other elements.
Let's use it to itself.
Exactly. And
Yeah.
that's actually part of what makes it so useful, But more importantly, it's incredibly light. Only hydrogen is lighter, in fact. So you put those two things together, and what you get is helium that, once it's released into the atmosphere, there's almost nothing holding it down here. Earth's gravity just isn't strong enough to keep it around.
So basically, every time one of those balloons we were picturing earlier escapes, it's not just disappearing from view, it's literally leaving the planet.
Yeah, that's it. Gone forever.
Yeah.
Makes you think twice about letting go of those balloons, huh?
It does.
Yeah.
It's a good visual, too, to help understand why we can't just make more helium. It's a finite resource, and whatever we've got here on Earth, that's it.
Now, rewind a bit. There was a time when we didn't even know helium existed on Earth. This article talks about its discovery, which is a pretty interesting story in itself.
Oh, yeah, for sure.
Yeah.
The first time helium was detected, it wasn't even on Earth. It was in the sun.
No way, really?
Now, back in 1868, during a solar eclipse, scientists were observing the sun's spectrum, basically, the different wavelengths of light it gives off. And they saw this new yellow line, something that didn't match any known element. So they named this mysterious element helium, after Helios, the Greek god of the sun. Pretty cool, right?
That's amazing. So it started as this kind of solar mystery.
Exactly. And it wasn't until 1895 that a British chemist, William Ramsay, actually managed to isolate helium here on Earth. He found it while studying the gases given off by uranium ore.
So for a while there, helium was this kind of exotic element, this scientific curiosity. Nobody really knew what to do with it, did they?
Not really, no. It was intriguing, sure, but there weren't any practical applications for it at the time.
But then came the 20th century. 2 world wars. And suddenly, helium wasn't just a curiosity anymore. It was strategically vital. What changed?
World War I was the real turning point. The United States saw that helium, being non-flammable, could be a game changer for airships. Think about it.
Uh-huh.
They're using hydrogen back then, which is, well, extremely flammable, not ideal.
Not a good look.
Not at all. So helium offered a much safer way to use airships, for things like reconnaissance and stuff. And the article really emphasizes this moment, calling it a eureka moment. And then World War II comes along, and helium becomes even more crucial. It starts being used in rocket propulsion and cooling nuclear reactors. I mean, it's everywhere.
From scientific footnote to a military necessity.
Right.
But how did it go from that to something we use in, like, grocery store scanners?
That shift happened because of some pretty significant discoveries here in the U.S. in the early 1900s. You see, drillers in Kansas found these natural gas deposits that wouldn't ignite. Strange, right?
Definitely unusual.
Yeah, and when they analyzed it, turns out these reserves had a super high concentration of helium in them. It was a game changer. Suddenly, we realized helium wasn't just locked away in some rare minerals. It was trapped underground, mixed in with natural gas.
So we go from trace amounts to these substantial underground reserves.
Exactly.
And the U.S. really took advantage of that, right? Built that giant helium reserve in Texas. And for a long time, it was basically the world's main supplier.
Yeah, pretty much.
Do you think that lack of global competition maybe played a role in the situation we're in now, with the potential shortage? Like maybe it didn't push other countries to look for their own helium sources or to conserve it as much?
That's an interesting point. And it's certainly possible. Having that one dominant supplier could have led to, less urgency in terms of exploring for new reserves or developing ways to recycle helium more efficiently. It's hard to say for sure, but it's definitely something to consider.
Because now, fast forward to today, and helium is everywhere. We use it for so many things. It's kind of mind-blowing. And it's not just about balloons anymore.
No, not at all. I mean, yeah, those party balloons are the most visible use for a lot of people. But honestly, that's just a tiny fraction of the total demand. Think about healthcare, MRI machines. Those use incredibly strong magnets that need to be kept super cold, almost at absolute zero. And that's where liquid helium comes in.
To keep the magnets cool.
Exactly. And when those magnets are that cold, they become what's called superconducting, meaning they can conduct electricity with practically no resistance. And that's how they can create those really powerful magnetic fields they need for imaging.
So no helium, no MRIs.
Basically, yeah.
Yeah.
Pretty important stuff.
And the article mentions quantum computing, too, which is like the next frontier of tech. What's helium's role there?
Well, quantum computers need to operate in extremely cold environments as well, near absolute zero. And you guessed it, helium is crucial for getting down to those super low temperatures and keeping things stable. And then there's the whole semiconductor industry, which is, the foundation of all our electronics. And guess what? Helium is critical there too.
So this affects our phones, our computers, even AI.
Absolutely. Helium is used in all sorts of ways in making those tiny chips that power everything. Like there's this process called plasma etching, where they use a plasma containing helium to remove material from silicon wafers with incredible precision. And that's how they make those intricate circuits on microchips. Helium is also important for keeping the equipment cool and for getting rid of contaminants. They need to keep things super pure when making those chips.
So no helium, potentially no advanced smartphones, no cutting-edge AI.
It's all connected.
So what else is helium used for that people might not realize?
Okay, well, we've got the space industry, which uses a lot of helium. Like, they use it to pressurize fuel tanks in rockets, making sure the fuel flows properly, even under those crazy conditions during launch. And then it's also used to keep sensitive instruments on satellites nice and cool, which is important because space can get pretty hot and cold.
Right, totally different environment up there.
And even deep sea diving uses helium. Divers who go really deep use a special mix of helium and oxygen to breathe, and that helps prevent something called nitrogen narcosis.
Nitrogen narcosis, what's that?
It's basically like getting really disoriented when you're under high pressure, like deep underwater. Nitrogen can have that effect, but helium helps to prevent that. And then last but not least, those barcode scanners at the checkout, those use helium neon lasers. So yeah, it's in a lot of things we use every day.
It's truly everywhere. But here's the concerning part. We're facing a potential shortage. Why is this happening if we've found all these reserves?
Well, the core issue is that helium is what's considered a non-renewable resource. Once we use it, whether it's vented from an MRI machine or, a balloon floats away, it ends up in the atmosphere, and eventually it's just gone. We can't make more of it like we can with some other things.
So we only have what we can extract.
Exactly. And to make matters worse, the supply is mostly concentrated in just a few places. The U.S., although those reserves are dwindling, and then Qatar and Algeria. So you've got geopolitical tensions, natural depletion of reserves, and that creates bottlenecks.
And to top it all off, demand is going through the roof, especially with the semiconductor industry booming thanks to things like AI.
Yeah, it's like a perfect storm, really. The article projects that the demand for helium could nearly double by 2035, and a big chunk of that increase is because of the need for helium in making semiconductors. The thing is, for many of the applications in that industry, there aren't any good alternatives to helium. So if the supply can't keep up, we could see some major price hikes.
Wow. I have to admit, when I first heard about this potential helium shortage, I thought, okay, maybe some labs will have trouble, but it won't affect everyday life that much. But then the article brings up weather forecasting and how a helium shortage could impact that.
Yeah, it's not something you'd immediately think of, is it? But think about it. Those weather balloons, they get launched every day all over the world. They rely on helium to lift them up so they can collect all that important data about the atmosphere. Temperature, wind speed, humidity, all that stuff.
Right, so we can know what the weather's going to be.
Exactly. And because of the helium shortage, the article says that the U.S. National Weather Service has already started reducing the number of balloons they launch. And that's not just an inconvenience. That could have a real impact on how accurate weather forecasts are, and it could mean less warning time for severe weather events like big storms or heat waves.
That's a pretty big deal for everyone.
Yeah, it is. It really shows how far-reaching the effects of this helium shortage could be.
The article also talks specifically about how this shortage could hit India pretty hard.
Yeah, and that's because India is totally reliant on imports for its helium supply. So they're super vulnerable to any fluctuations in the global market or any disruptions to the supply chain. If the amount of helium available drops significantly, it could have a knock-on effect across all sorts of important sectors in India.
Yeah.
Healthcare, electronics manufacturing, space research, the growing AI industry. It really underscores how interconnected everything is globally.
So it's a complex problem with potentially serious consequences. But the article does offer a glimmer of hope, the discovery of those big helium reserves in Tanzania.
Yeah, that was a pretty significant find back in 2016. Initial estimates suggested there could be something like 54 billion cubic feet of helium there. That's enough to fill over 1 million MRI scanners.
That's a lot of helium.
And some later assessments have indicated that the actual amount could be even bigger than that. What's really promising is that just last month, in March of 2025, Tanzania issued its first ever helium mining license to a company called Helium One Global. If their operations are successful, Tanzania could become a major new player in the global helium market, and that could help to ease the strain on existing reserves.
So a potential game changer. But, thinking about the history of resource extraction, are there ethical considerations or geopolitical factors that need to be taken into account as those reserves are developed?
Oh, absolutely. We have to think about the long-term impact on the region, both environmentally and socially. And it's crucial to ensure that the benefits of these resources are shared equitably and that the development is done sustainably. It's not just about getting the helium out of the ground, it's about doing it responsibly.
It's definitely a multifaceted situation. So while we wait to see how things develop in Tanzania, what are other countries and industries doing to deal with this potential helium shortage?
Well, the article highlights a few things. Some countries are looking into the possibility of creating strategic helium reserves, similar to what we do with oil. This would give them a buffer in case of supply disruptions. There's also a lot of investment going into helium recycling technologies, especially for things like MRI machines, where capturing and reusing the helium is becoming more and more feasible from an economic standpoint. And of course, researchers are always looking for alternatives, trying to find other gases that could be used instead of helium in certain applications. But as we talked about earlier with the semiconductor industry, finding something that can truly replicate helium's unique properties is a big challenge.
So the solution involves finding more helium, conserving what we have, and exploring alternatives. It's a multi-pronged approach for sure. But as the article emphasizes, until these new sources come online and recycling becomes more widespread, we really need to start treating helium like the precious and irreplaceable resource it is.
Exactly. Because once it's gone, it's gone.
What really struck me from this deep dive is how this seemingly simple, even silly gas, helium, plays such a crucial role in so many aspects of our lives. It's everywhere.
It's really quite fascinating, isn't it? Who would have thought that this element, first discovered in the sun, would become so essential for everything from quantum computers to weather balloons?
And it's true what they say, what goes up must come down. Except for helium, it seems. Once it goes up, it's gone forever.
It really makes you think. What happens if those reserves in Tanzania don't pan out the way we hope? What if demand keeps growing faster than we can find new sources or develop alternatives? What kind of world are we headed toward if helium becomes truly scarce? These are questions worth pondering.
It's a bit of a reality check, isn't it? Those balloons we started with, that image of them floating away, it's a nice visual representation of how easily we can lose this incredibly valuable resource. And it makes you wonder, is our fleeting enjoyment of those balloons worth the potential cost of losing access to helium for all these vital applications?
It's a question we all need to consider.
Lots to think about, even after our deep dive ends.